Okay, very good afternoon. Am I audible clearly? Are you getting my voice? Is it audible? Okay, so hope you have enjoyed your food also, and you may have enjoying the training sessions also that we are conducting from last week, right? And just if you want to speak more about the current ongoing training sessions, see, mostly frequently I am telling about these activities which we are conducting through the TPOs. Apart from academics, it is very, very important because see, up to some limit, there are some limitations for the academics. And beyond that, ultimately, you will have to work on your skills. And skills can be worked out properly or it can be enhanced just by getting the trainings frequently. That is the only option. Once you will get the exposure frequently, your skills will get enhanced. Okay, so just enjoy the sessions. The motto behind giving such sessions is that hopefully or probably in your final year you may going to face the online interviews, because we don't know what is going to be the future situation. So probably you will have to also face the online campus drive. That time we should know everything about this online campus drive, how to face the interviews online, because there is so much of huge difference between face-to-face interaction and online interaction. Right, sitting in front of the system and sitting in front of the person is a totally different thing. Okay, so enjoy the things and try to get what maximum possible from whatever the sessions we are giving. Okay, if you are having any problem related to the trainers or the sessions or any queries, okay, so you can get in touch with the Vikram Chauhan sir or your class coordinator, or you can be in touch with me also. Okay, so let's start with your second lecture. We are discussing about the plastic engineering, very interesting subject. And interesting, and I can say that it is going to be a totally different subject. As I told yesterday also, it is like an allied subject in the sense it is not directly connected with the mechanical engineering. It is like a multidisciplinary subject, and whenever you will get opportunity to know about such concepts, it is always interesting type, because it's totally new. What are the things you have learned your maybe machine tools subject, or maybe in the manufacturing process, that was just core subjects that were actually a core subjects, simply a manufacturing processes, a basic understanding. But the application of that is you will find it in a plastic engineering. Okay, it is a product based subject, right? That's the things. So, and even if you see in the industry also, this is having a wide range of applications. Getting it starting from your day to day products to the advanced products maybe used in this space, in the uh, war like situations or war equipments, right? So slowly we will see that also the applications in each and every field, right? So today we are going to start with our first chapter, and the first unit is regarding the basics of the plastic, right? If you are having any or a problem with respect to my voice or the speed, then you can just chat in between, right? So the first topic we are going to discuss about basics of the plastics. Basics in the sense, why the basics are required, because this is going to be a new platform for you understanding about the plastics. And whenever you will go ahead, you will see that there are some roots engraved into the chemistry. You have faced the chemistry also in your first year, in your 12th standard also. Okay, core chemistry we have seen there, but we are not going to deep into the chemistry part, because it is a quite or very different part. Chemical reactions and bondings and atoms and molecules and so many things. Okay, it is totally different part, but there are roots of these plastics in the chemistry. So just some sort of information we will take out from the chemistry, and then we will move ahead with the plastic part, because we are going to see deep about the application oriented part, and not the basic manufacturing part. Okay, some manufacturing process obviously we are going to see, but not at a molecular level or atomic level, right? So here we are going to study basically about the definition and classification of plastic materials, then its properties, applications, testing methods, and here is some chemistry part: monomers and polymers, polymerization, types of polymerization. But it is and just an average part, not so much from the chemistry. Then applications in various areas such as agricultural, packaging, which is the largest industry, building, transport, electrical, electronics, medical, furniture, and so many things, war equipments and space equipments, everything, everywhere you will find the application of this particular plastic, right? So now if you see this particular content, apart from that, we are going to see some historical background also, right? Because see how it is evaluated, until and unless we are not having information of that, then see, if you don't know the history, we don't have the motto to see the future, or we cannot imagine the future. If we know the historical background, then we can predict, or we can see the future, or we can get the future. Okay, so that though it is not in the syllabus, some part of historical background, how plastic use or how plastic came into the picture, that we will see. Okay, obviously it is not part of your university curriculum, so it will not be there in your exams. Okay, so let's see first of all that part, how the plastic has started coming into the picture, how it has introduced into the human life, and then how it has encroached entire industry. Encroached in the sense, even it is nowadays replacing all the ferrous materials, metallic parts, and it is taking the place of that particular uh, materials, right? So it is replacing each and every other materials. So the first part, let's see some of the background of the plastic, how it is evaluated, and then we'll go ahead with the definition and the classification part. Okay, okay. So currently, plastic is said to be an most versatile material on the earth. Versatile in the sense that, uh, with respect to application, as I told yesterday also, that if you wake up in the morning, you will have nowadays you will have your mobile in your hand, because your day start with the mobile and your day end with the mobile. But if you see, you will have your toothbrush in your hand, made from the plastic. Okay, covering of the toothpaste made from the plastic. Okay, then you will going to have a tea or the breakfast. Okay, there you will find so many applications of the plastic, starting from the cup, then your glass, then your cooking pans, and so many appliances in the kitchen, as like a mixer, a fridge, so many things. Okay, starting from that to the your working place. If you see in your at the working place also, your table, furniture, systems, like I mean PCs, then chairs, your fans, electrical cables, right? Their coverings, everywhere you will find the application of plastic. And to the last point, okay, so it is an versatile material, right? So almost all of these products we use in our daily lives contains plastic. Okay, so let's see how this plastic has encroached, or how it is entered into the human life, and now how it has become undifferentiable part of the human, right? So everywhere you will find the plastic, even your water bottles made from the plastic, your tiffin box made from the plastic. Okay, everywhere you will find the application of plastic. Okay, now see the some early stages of the plastic. Now see, if you see any kind of product, any kind of culture, except Indian culture, or any other evolution, it has mostly started from Egyptian, that territory, or Egyptian era. Because Egypt peoples or Greek peoples are known for innovation. They are known for innovations. Okay, you may have known about the great pyramids, mummies or pyramids. Okay, so that is also their invention. A pyramid is not a simply a historical structure. There is so much of science behind that. There are so many inventions behind that. Okay, starting from building of the pyramids, that internal structure, internal atmosphere. Because if you see the history, whatever the bodies are there in that particular pyramids, they have kept these bodies are stored from more than 500 and 1000 years. Still, a decaying period or the decay of the body is very less. Decay of the body is very very less. So you will find interesting science behind it. Okay, so Egyptian peoples or Greek peoples are known for the invention. Okay, so here are some just a minute. Right, so like see, here is the invention that is made by the Greek peoples. What they want to know, so the Greek peoples are known for their pyramids or their mummies. Okay, the way they are storing that uh, they had stored their mummies. Okay, so it is given here, would wrap their dead with cloth and resin, which would harden into shell. Okay, now see, read the sentence carefully. Would wrap their dead with cloth and resin, and which would harden into shell. Okay, so if you have seen the Hollywood movies also, The Mummy Returns. Okay, there you may have seen that particular structure of the mummy. Okay, there is a very hard cloth wound around that particular body. You may have seen that. Getting it? So actually, what they have done, see, if you simply wound a simple cloth, a cotton cloth around the body, it will decay very fast. Because even a simple small insects also they can decay that particular cloth. Okay, but what they have done that time, at that time they have mixed resin along with the cloth. So they have wound the cloth around the body and they have implied this resin over that. And because of the temperature difference, that resin is going to get hardened along with the cloth, and it is going to form a very hard structure. Very hard structure, a structure like uh, mm, you will see on the backbone of that tortoise. Right, if you see the backside of the tortoise is so hard. Okay, that type of structure is formed around the body, and because of that, the decay of the body was very less. Right, so it was the invention, the mixing of cloth and resin. And cloth is nothing but what is the how the cloth is made. It is made from the cotton, and the cotton contains a small or large quantity of small cellulose fibers. It contains a large quantity of small cellulose fibers, and that fibers are working as a right origination for the plastic. Okay, so the word plastic, that is actually invented from the plasticos. Keep it in mind, plasticos, and this plasticos is a Greek word. See, most of our English words have taken from Latin and Greek. Their origination is from Latin and Greek. Okay, so it is originated from the Greek with the name plasticos. Plasticos. Okay, like our word school. School is also originated from the Greek word schola. 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 And the Greek people, they were having the culture like that. At the time of evening, they used to collect together under the one tree. Because in their history, if you see the history, whatever the villages were there that time, they used to have a very large tree at the center of the village. And at the evening, all the village peoples used to collect there at the evening, and they used to discuss about the just our routine discussions. And for that place, they have given the name as a schola. And then after that, schola has become into school. Getting it? Okay, so a different story. So the plastic is originated from the plastic codes. Okay. Second, the plastic, the first plastic that was not that time, it was not known as a plastic, but it was a keratin. It was a keratin. Okay. If you see the history of keratin, it is a protein like structure, keratin. Okay. uh, Maybe if some of you have studied about the biology and zoology, okay, zoology and botany, you may have came across this word keratin. Okay. uh, if you see the body structure also, you will see this keratin in your nails, in your nails. आपण जे हाताचे आणि पायाचे नख असतात त्याच्यामध्ये ते केराटीन असते. ओके. So that keratin was the first start of that particular plastic. Okay. Natural plastic. So that keratin is existing in a nails. Okay. So the our human nails, then animal hooves, horns, and turtle shells. Okay, these are all hard structure. Okay, these are all hard structure. So that keratin is found in a that particular structures, and that keratin was the first plastic, natural plastic. Okay. And that time they were making the combs from it. Okay. Kangwa, right? So that combs were made from that particular material, but that was used to taken from animal hoops. ओके, ज्याला आपण हत्तीचे शिंग म्हणतो किंवा जे शिंग जे असतात, ओके, दॅट हॉर्न्स और हूप्स, दॅट they were using that horns and hoops for the products. But after that, that ban was started because of the killing of the animals, and that process has diminished afterwards. Second was the this was the old era, and this is the modern era. You can see it is the second phase. So this is the person known as Alexander Perks. It is around 1862. Okay, so he has developed semi-synthetic plastic. Okay, so understand the meaning of the semi-synthetic. Semi-synthetic means you will add some another material into naturally available material, a mixing, a composite. Okay, so you will add some another material into naturally available material, and that is called as a semi-synthetic. And he has developed this Perkins sign. That is one of the plastic. Okay, with his name only. And the property he was having was it could be heated and formed. Means it can be heated and it can be reshaped or reformed. And then he manufactured so many items like our buttons, shirt buttons, combs, small picture frames, and pens. Okay, see here this picture is also given. Getting it? Okay, so it is made from the semi-synthetic plastic. Then this is the person Hath. Okay, around 1868. He has also used different materials, and he has developed a commercial plastic and similar type of products, combs, shirt collars, cups. Okay, that time shirt collars were made of plastic. Okay, nowadays it is a of cotton only. Cups, billiard balls, and films. Okay, that film strips, right? But the problem was that it was a very flammable material. Currently also there are flammable properties with the plastic, but it has reduced to so much of extent. And now then this revolution started from the Backland, which he has developed bakelite, a very famous plastic, a first 100% synthetic plastic. Getting it? Okay. So see, let's have some discussions over this point. See, in old days or in nowadays also, for whatever the electrical cables are there, nowadays also you will find some of these things around that electrical cables or a wire, like that copper cables. You will find a rubber coating over that, sheathing or coating over that particular copper wire. Okay. Print card. Just a minute. याच्यामध्ये आहे फर्स्ट पेज, लेट हेडर दोन कॉपी. Okay, so see, there was a problem with the rubber. Currently also some companies are using rubber as a coating for the electrical wires, but see, the electrical wire made from the copper, when huge amount of current is passed through that particular copper wire, getting it, you know that if current density is very high, you will find increase in the temperature. You will see the electrical appliance also, whenever there is a fluctuation in the current density, you will see that particular heating of the filament. Getting it? So because of the heating of the filament, that rubber used to get disturbed, or it will melt immediately because melting temperature of the rubber is very less. So that was the problem. Okay, so that uh, from 1990 or around 1950, that rubber started to replace by this plastic. Okay, so again there are so many products like phones, cameras, and special arts, right? And from that, that thermosetting and thermoplastic concept have started. Okay, war developments also. Okay, currently also there are having less applications of the plastic in the war, but mostly the plastic is nowadays it is used in the space shuttle also. The reason behind is the less weight and good strength is the reason behind the use of plastic for the space shuttle vehicle manufacturing. Okay, space shuttle manufacturing. Because if you go for the metallic materials will give you the good strength, superior properties, but it will have, because of the density, it will have more weight, and more weight will cause into requirement of more fuel, and the fuel requirement is the major issue with respect to space shuttle. Getting it? Okay, so that they have started replacing the metallic materials with the plastic. Now, after the war developments, like Second World War and First World War, so many plastic have developed, like polystyrene, nylon. Nylon is currently you will see everywhere the use of nylons, and just yesterday also I have given the example of toys. Okay, 99% toys are manufactured out of the plastic. Getting it? And even whenever there are less efficient applications are there, even gears are also made from the plastic. The problem only is that uh, because of the continuous rubbing, there will be the friction with the teeth of the particular gears, and efficiency goes down. So that gears are mostly preferred out of the metallic material. But if the application is of that type, like if application doesn't require any power transmission, then you can use the plastic also for the manufacturing of gears. Then so many examples are there: polyethylene, Teflon, polycarbonate. One by one, we'll see separately. Okay. And this is what about the current day. Current day, everywhere you will find the application of plastic, as I told. Okay. Water bottles, packaging, plastic bottles, everything. Okay. So, basic two things: why to use plastic and why not to use plastic. The first thing, advantage is that, see, looking to the product also you can predict the advantage. First thing, as I told, lightweight, strong, flexible. Getting it? Rigid, surface finish is very good. Okay, will not having the problem of corrosion, and inexpensive also. But the major issue is with the non biodegradable factor and hard to repair. आणखी एक काढले ना? आणखी. Okay, two major disadvantage: hard to repair and non biodegradable. Getting it? Now let's work on this. See, hard to repair means what? If you see, a very simple example we'll take, baby toys. Have you seen the baby toys? Simple toys. And if you see the good quality of ties made from the plastic, there are some small screws, or we cannot say nut and bolts, but small screws are there to attach the part. Now, after using it for some time, when you will or that because of the continuous use, if you will found that that screw will not be at its own place. Okay, it may have lost, or it will not be there. Now if you try to rearrange the screw at that particular place, it is very difficult. Now if you see with the wood structures or the metallic structure, arrangement of the screw or nut and bolt is very easy. You can easily, okay, You can easily tighten it, you can easily lose it. Easily, just a minute. Tight it, or you can easily lose it. Okay, because it is having, yes, it is having superior properties with the metallic materials, but with the plastic, that is a major disadvantage. If you purchase a large size furniture made from the plastic, and see, in case of furniture there are so many screws because so many different parts are attached to each other, and if you will lose some any screw from that, and when you will try to adjust another screw at that particular place, it is very difficult. Means it is as like a one time use. So once that part will broken, then you cannot readjust another part at that particular place. Getting it? Okay, so that is the major issue. Hard to repair, hard to repair. And second is a non-biodegradable factor. That is a major issue. So that there are so many concerns about the plastic bottles we are using for, uh, like our regular plastic bottles, water bottles, even our milk bags made from the plastic, right? Our carry bags made from the plastic. The major issue is that non-biodegradable factor. It cannot be uh, easily biodegradable because of the continuous chain of monomers. Again, that is the chemistry part. Okay, but the major issue, there are two major issues: hard to repair and non-biodegradable. Okay, non-biodegradable and hard to repair. And one more small issue is poor tolerance with respect to heat. Means what? If you keep it in a open atmosphere in a summer days for around 2 to 3 hours, you will find that it has reshaped. It will melt down easily. Okay, so wherever there is a case like a case of the high temperature, or the applications with are going to use for the high temperature applications, there you cannot use the plastic. Major disadvantage. But your question will be that then how you are saying that plastic can be used for space shuttle vehicle manufacturing? How NASA will use the plastic for their space shuttle? Because I told you that uh, the major advantage is that less weight and good quality, good strength. But disadvantage is that poor tolerance for the heat. But see, plain plastic you cannot use in that case, right? Issue is that it will be a composite plastic. It will be a composite plastic. So in that product, plastic will be used to reduce the weight and get the good strength, and another fibers are reinforced with that to get the good quality of heat resistance. That is called as a composite plastic. Okay, so that can be used, or that disadvantage can be overcome. So this was the background of the plastic. We have seen old historical background also, from early stages, modern stages, and current also. What is going currently and what is required to do. Let's see now our regular part, a definition of the plastic. Okay. See, whatever we are learning, it should not require to recall. You should understand it easily. Now, looking to the all the historical aspect that we have discussed, whatever the discussion we have made, you can easily define plastic by your own. And if you can do that, then that means that you have understood whatever I have told. Okay? Simple thing. A plastic is a material which can be reshaped or remolded by the application of heat or pressure. Simple definition. Getting it? Which can be reshaped or remolded by application of heat or pressure. It may be synthetic or it may be naturally occurring. Synthetic means we are going to add some material into naturally occurring material, and that will create a synthetic plastic. Okay, so a simple, a material which can be reshaped or remolded by the application of heat or pressure, by the application of heat or pressure. Now, in some cases, with some huge pressure also, you can change the shape of the plastic. In some cases, you require to heat that particular plastic. In some cases, you require to heat that particular plastic. Okay. So let's see. I have one video. Just a minute. Okay. Are you getting the voice? Are you getting the voice of this particular video sound?
Yes, sir.
Okay, chalo. See it carefully. What you will call this structure as? What you can call this structure as? You have studied in your casting also. For see, when you are having any molten metal or molten material, if you want to reshape into a different structure or a size or shape, you need to have a mold. You need to have a mold. Okay, mold is nothing but the prototype of the product what you require. Getting it? Okay, so this is the mold. See it carefully. See it carefully. And this is the structure that we want. See, he is having this sheet, a plastic sheet. Okay, and we have to reshape it. We have to reshape it into a cylindrical structure type, a glass type structure, right, without top and bottom. Okay, now he is hitting that. Okay, but hitting should be up to some level. If you cross that level, it will start melting. Okay, okay. Here are there are two applications. Getting it? First is the application of heat. Okay, which will which will um, restructure that particular material. Okay, there will be breaking of the bonds at the, if you see at the molecular levels. Okay, so which will cause to flow of the material. Material will flow as like a liquid, not as like a liquid, but as like a semi-liquid, so that it can be reshaped into any type of structure. And then there is the application of pressure. Getting it? Simply application of heat will not make uh, the required product. Heat along with the pressure. Allow it to cool down. Okay, okay, I know I need some answers. Why he is pouring the water? Why he is pouring the water? The reason behind he is pouring the water. Cooling. Okay, now can I pour oil instead of water? Next question. Can I pour oil instead of water? Purpose is same. Water will also cool the material, and oil will also cool the material. Now, can I pour here oil? Forget about the dirtiness, because whatever the dirt will happen because of the oil. Forget about that non-technical part. But major issue is cooling of the particular part. So instead of water, can I pour the oil? So you are saying no, yes. Right. Now, see, again, technical concept. Now, when just give me the answer. Now, there are two products heated at some suppose 90 degrees Celsius temperature. Okay, heated at some 90 degrees Celsius temperature. Two products made from same material, heated at the same temperature in the same atmosphere. On one of the product, on the surface of one of the product, I will pour the water, and on the another surface of the product, I will pour the oil. Which product will cool down fastly? Cooling rate, where I will get more cooling rate in case of water or in case of oil. In case of water or in case of oil. Water. Anyone with oil? Water, water, water. Okay. Now, this will be your homework. Okay. Just check it. Just check it. Okay. So these are actually conceptual questions which are mostly asked at the time of interview. Okay. So learning should be like this only. Simply just reading the statements and just omitting it at the time of exam will not give you the proper future. Okay. Whatever you will learn, you should be able to understand the hidden meaning. Okay, so immediately there should be a question in your mind. If he is pouring here water, instead of water, if I will pour another liquid. See, what is the basic difference between water and oil? Density. Getting it? Density is the basic difference between the, forget about the chemical structure and it is already different, but major issue is the difference between the density of water and density of oil. Who is having the more density? Water or oil? Who is having the more density? Water or oil? Density, Bharat. Who is having the more density? See, dense means what? ज्याला आपण घट्ट म्हणतो. Okay, dense means where atoms are very closely packed. Okay, so density of the oil is more. Density of the oil is more. Density of the water is less. Getting it? Density of oil is more and density of the water is less. Okay, so it is directly related with the density of the water and density of the oil. Okay, so density of water is less and density of oil is more. Now, next question. Can you tell me what is the density of water? What is the density of water? This is the question from I think 2002 GATE. Okay, not a direct question, but there it is required. There it was required. Density of water. Density of water. Okay, great. 1000 kg per meters cube. 1000 kg per meters cube. Okay. Now you have studied your fluid mechanics. You have studied the fluid mechanics. Now tell me. I am speaking about the water. Is it compressible or incompressible? Again, the question with respect to density. Is it compressible or incompressible? With respect to water, is it compressible or incompressible? Incompressible, incompressible, incompressible. Okay, getting it? Okay, right. Okay, right. Okay, but now see, if you get this question, such type of question with respect to density. Now this question is with respect to density. If you will give the pressure and if you will get compressed means if you give the pressure and density increases. That means it is getting compressed. Then you will call it as a compressible, right? You will call it as a compressible. Theoretically, water is incompressible. Actually, see, answer should be incompressible only. But if you face an interview like ISRO, DRDO, BARC, if they will ask similar question, water is compressible or incompressible, your first answer should be to the some extent it is compressible. To some extent it is compressible. Okay, but as an average it is incompressible. Reason: if at the normal atmospheric condition density is 1000 kg per meters cube, means suppose for example if I will say at the 1 bar pressure, at the 1 bar pressure it is a 1000 kg per meter cube. If I will increase pressure from 1 bar to 100 bar, 1 bar to 100 bar, I have increased the pressure 100 times extra. That time there is a change of around 0.05%. There is a change of around literally 0.05%. So it is a neglecting type change. It is getting compressed, but that compressibility is a neglecting type, so that ultimately it is called as a incompressible. Getting it? Okay, keep it in mind, such things. Okay, we'll continue this. So now this is a mold removing process. See the joint, see the joint. Okay, so that's how it is reshaped or the remolded. It is reshaped or remolded. So now there should not be, you should in future whenever anytime anyone will ask you about the definition of plastic, you should not forget it, or you need not to open the uh, dictionary or book or your mobile. Okay, simply you can sell that by the application of heat and pressure. If material get reshaped or remolded, it is plastic. Okay, it is plastic. Sometimes heat, sometimes pressure, sometimes heat and pressure, combination of both. Okay, so this is the definition of plastic, right? Next part is classification of plastic. Now if you see, if you refer the various books, different types of classifications are there, but we'll see the generalized classification, because classification is there with respect to these three criterias: how it is behaving or reacting with respect to heating. Means if once heat is supplied to that particular plastic, how it is reacting or responding. According to that, there are some classifications according to the structure and according to the physical and mechanical properties. Okay, but ultimately there is one basic common platform in which all the plastic will fall in that particular two groups: thermosetting and thermoplast. And every time you will see only these two words: thermosetting and thermoplast, because all these groups will fall in that particular two categories. Getting it? Okay, so the first one, just for your understanding, natural plastic. Natural plastic. Okay, now don't read these lines, directly see the picture. Have you seen these around your home? Have you seen this type of material just on some trees? Have you seen this in your village, in your city, in and around you? Okay, you may have seen this. ओके, आपण ज्याला मराठीत म्हणतो बाबळीचं झाड जे असतं, ओके, त्याच्यावर बघा तुम्ही लिंबाचं झाड बघा. ओके, लेमन tree also, you will find this type of material on that particular tree. Okay, This is called as amber. It is called as amber. Okay. Now, if you see, when it is secreted from the wood, you will see it is a glossy like, some type of semi-liquid type. And once it gets hardened, you need to have stones to break it. That's how it is getting hardened. Okay, so it is a natural plastic. It is naturally appearing plastic. Now, if you want to change its shape, just hit it. Just hit it. It will again melt down. Okay, you will see this on the surface of the trees. On the surface of the trees. Okay, so it is naturally occurring plastic. Okay, why I have given the name here plastic? Why I have telling this as a plastic? Go to the definition. What? Which can be reshaped or remolded by the application of heat. Same thing is happening here. Once I will apply the heat, it will melt down, and I want whatever the structure I want, I can get it. Okay. Now, this naturally occurring plastic, which is called as amber, you will see this plastic on the jewelries. Okay, you see, if you see the stones on the rings, okay, what is jewelries are there on that, the stones are there. Okay, that stones are made from this particular amber plastic. Getting it? Okay, obviously some additions are required, then only it is used. Okay, but it is a naturally occurring plastic, right? So time is around 3:53. Okay, one more thing we'll see. This is a natural plastic which is appearing on the wood, which is called as amber, which is called as amber. Mostly applications are in the jewelry. And second is a semi-synthetic plastic. Okay, semi-synthetic plastic. I have told you the meaning. You add some materials, you add some material into the naturally occurring material, you will get the semi-synthetic. Okay, so this is a film. Okay, nowadays it is not used, the digital things are there. So but on old days these films are used in camera also, and in the that videography also. Okay, these films or the structures of your sunglasses. Okay, specs. So basically these were made from cellulose fiber and the acetic acid. Cellulose fiber and acetic acid. Cellulose fibers are simply as like your cotton fibers. Cellulose fibers are simply as like a cotton fiber. But the issue with the cotton fiber or the cellulose fiber is that mistake. Okay, so issue with the cellulose fiber is that less strength. Okay, so that this acetic acid is added into that, so you will get a good density also, and this strength also. Okay, so that this is called as cellulose acetate. Okay, so this your sunglasses structure, and this films are made from this cellulose acetate. Okay, need not to go in a depth of the chemistry because this is a totally chemistry part. Cellulose and acetate and acetic acid. Okay, simply you can keep it in mind the applications. Semi-synthetic plastic. Okay, this classification also not asked in your exam, but for your information, I am taking directly. It is asked thermosetting and thermoplastic. Okay, that we will see tomorrow. Okay, so whatever learned today, natural plastic on the wood, on the trees, and historical background. Obviously, the definition of plastic, a simple definition: material which can be reshaped or remolded by application of heat or pressure. Okay, this is what for today, and tomorrow we'll see synthetic plastic, and the most important, every time it is asked in all the exams, our university exam will be at the bottom. Getting it? Apart from that, in all the exam, these things are used. Sorry, asked. Difference between thermosetting plastic and thermoplast. Okay, so tomorrow we'll see in a depth about this, what is thermosetting plastic, why it is called as thermosetting, and then second is the thermoplast, its applications, its properties, why that properties are like that. So because properties are there with material because of the structure. Properties come from the structure. Getting it? Okay. So that we will see tomorrow. So we'll stop here for today. Just a minute.